See the latest solar eclipse from space. A future supercontinent will wipe out all the mammals. Juno makes a close flyby of Io and a planet with clouds made of sand. All this and more in this week's Space Bites. Well, I hope you got a chance to see last week's annular eclipse. It was visible from people in North and South America, and I had pretty nasty weather leading up to the eclipse, and it was like clouds everywhere. And then I got this like slight part in the clouds where the clouds were thin enough that I could actually see the sun blocked by the moon. And where I live on Vancouver Island in Canada, we hit about 85% maximum totality. So it looked pretty cool, like a crescent sun in the sky. But then the clouds came back and it was gone, and then that was that. But if you didn't get a chance to see the eclipse, or you want to see like a really cool perspective, we've got a picture from space. So the spacecraft that took this picture is called Discover, or the Deep Space Climate Observatory. And it's sitting out at the Earth-Sun L1 Lagrange point and pointing back at Earth. And so it is always able to see the complete sunlit version of Earth, sort of a full version. It's got a telescope, it's looking at Earth, and it's releasing pictures of Earth several times a day. And by the way, like if you ever have someone who is like a flat earther and says, oh, why have they never taken any full blue marble pictures of the Earth on a regular basis? They have. It exists. It's done. So I love looking at pictures from the Discover satellite, because you see weather patterns on Earth that are, there's large hurricanes, things like that. You can actually see them in this picture, and it's updated every couple of hours. So people have made cool animations from Discover. I know Scott Manley has made a couple of videos about this, about how you can work with Discover data and produce images of Earth and animations and things like that. And so from this perspective, you can see what an annular eclipse looks like as it's moving across the surface of the Earth. And an annular eclipse is different from a total solar eclipse because the moon gets closer and farther to the Earth, and the Earth gets closer and farther to the sun. You'll have times when the moon doesn't perfectly block the sun in the sky, and you get what they call a ring of fire effect. And so the moon is like this disk that passes in front of the sun, but still the sun is leaking out on all sides of the eclipse. And that's what this one was. And so instead of getting like a really nice tight shadow with a surrounding hazy penumbra, it's all sort of hazy because there was no part that was in complete totality. And that's what you can see in this picture of Earth with an eclipse on it. So cool. Now remember, this is one of two eclipses that are going to be happening back to back. The next big one is going to be happening in 2024 in April. And we're only just a few months away. So if you haven't already planned, make sure you figure out where you're going to stay, where you're going to fly, how you're going to be able to see this eclipse. It's going to go from Mexico up through the United States into Canada and then out into the Atlantic Ocean. Total solar eclipses will blow your mind, and you really want to be able to see this. So if you're anywhere close to the eclipse track, try to get a chance to see the 2024 eclipse. A horrible future for the Earth. Earth has continents today. You've got the Americas, and then you've got Europe and Asia and Africa and Australia and Antarctica, and their current locations are just where we happen to be. But we know that thanks to continental drift, these continents have been moving around over time. And there was a time in the past when all of the continents were locked together, and they call this Pangaea. And in the future, all of the continents are going to come together again. And geologists are calling this Pangaea Ultimate. And this is going to happen in about 250 million years. It sounds like it's going to be cool, but it actually sounds like it's going to be pretty bad, because the way the continents are going to lock together, where they're going to be situated on the Earth, is right around the equator. And you're going to get this gigantic desert that's going to form. So if the weather patterns are moving from west to east, you're going to get these giant mountain range on the west side of this supercontinent, and then you're going to have this enormous rain shadow that's going to pass along the entire continent. And so geologists are thinking that temperatures are going to increase probably to like 40 to 50 degrees across this area. And then at the same time, we're going to have higher levels of humidity just in the atmosphere. And so you might get these conditions where most of planet Earth will be regularly too hot for mammals to survive. There's going to be parts at the top and the bottom of this megacontinent where the climate will be milder, and so you can have mammals exist, but the geologists think that probably like only 8 to 16% of the planet at this point will be habitable compared to how habitable it is today. And when you add on top the fact that the planet is slowly heating up because the sun is heating up over the next, say, 500 million years, the oceans will boil, the Earth will just become uninhabitable, and we'll be halfway there when we get to the 250 million year mark. So I'm trying to think yikes. Like, it just sounds like it will be a very unpleasant planet to live on at that point. So be grateful that you live on a world with lots of continents spread out across the planet. Juno makes a close flyby of Io. NASA's Juno spacecraft has completed its major mission at this point, which is to study Jupiter. And it makes these flybys every month or so, comes in, does a flyby of Jupiter, takes a bunch of pictures, and then flies back out, and then does it all over again. And this is sort of mostly designed to minimize the damage to the spacecraft as it enters this intense region of particles around Jupiter, works quickly, gathers a bunch of science, and then flies back out and then does the whole process again. Well, they've gotten the main part of the mission over with, and now they're in overtime. And so now they're starting to gather information about the moons of Jupiter. And just this week, it completed its flyby of Io, which is the closest of the big moons around Jupiter. Of course, Io is really fascinating because it has this volcanism across the entire surface of the world because of the tidal interactions between the planet and the moon. It's so extreme that it just like liquefies the inside of the moon, and you get like the most volcanism of anywhere in the entire solar system. This flyby came within 11,500 kilometers, and we got some great pictures from a bunch of citizen scientists, especially Kevin Gill, who's one of my favorites. He did a great job of sort of pulling the images off, processing them, and sharing them in a way that we can see them. There's 2 more flybys planned for the coming couple of months. The next flyby is going to be in December, and then there's going to be a flyby in February where Juno comes within 1,500 kilometers of the surface of Io. And that's going to be amazing. Like, that is so close. Hopefully we'll be able to see like volcanoes erupting and magma flows across the surface of this place. We really need more understanding about Io, and this is going to be a good first step. I'm hoping like these pictures will get everybody really enthusiastic and be like, we need a mission to Io. And to which I say, yeah, we do. Absolutely. An exoplanet with clouds made of quartz. Astronomers have been studying a hot Jupiter-type planet called WASP-17b. And we've known about this for a long time and known that it is an extremely uninhabitable planet. It is very close to a star. It just takes about 4 days to complete an orbit, and it experiences temperatures on its surface of about 1,500 Celsius. And these hot Jupiters are really puzzling to astronomers. How do you get a planet that is so big, so close to its star, and yet not be consumed by the star or not have been kicked out of the system, or should be pushed further out and migrated outward? How are planets migrating inward towards their stars? So this is the ideal target for the James Webb Space Telescope. Astronomers turned James Webb onto this planet and analyzed its atmosphere. And what they found is that it has clouds of quartz crystals of silicon oxide in crystalline form. And that's very puzzling because on Earth you need like a solid environment where these crystals can form, but they're forming in the atmosphere of a gas giant. And so what's believed is happening is that you've just got enough temperature and enough pressure in the outer regions of this planet that these quartz crystals can just grow in the atmosphere and turn into clouds. And so it has clouds of sand. Crazy. Every week we do a vote on our channel where you can tell us which you thought was the most interesting story of the week. And I've sort of struggled to explain how to find where this vote is. And so a lot of people have said, oh, it's really simple. All you have to do is go to my YouTube channel on my page and then click on the community tab, and then you'll see the votes there. I hope that helps. Or what I do is just scroll on my phone until these votes show up, and then I just click on the vote that I want and just keep scrolling. And so we asked you to tell us which of the stories last week you thought was the best, and the winner was a bit of a slimmer majority this time around, and that was that NASA had opened up the OSIRIS-REx capsule and looked at the samples inside. So thank you everybody who voted. Now, if you want to ensure the maximum chance that you are going to see that vote while you're scrolling, is subscribe to the channel. Aren't you subscribed to the channel? Why are you not subscribed to the channel? Like, if you watch these episodes, you should be subscribed to the channel. Have I mentioned you should subscribe to the channel? Subscribe. Have you subscribed yet? All right, let's move on with the news. A possible supervolcano on Pluto. All right, so I was browsing through the news yesterday, looking through all of the interesting planetary science papers, and this one popped out at me like it was on fire. So when NASA's New Horizons spacecraft flew past Pluto in 2015, like, we got the first pictures of Pluto. And for the longest time, like, I don't know about you, but like, when you look at books, you get all of the pictures of all the planets, and then Pluto is just like an artist's illustration. But then in 2015, we got actual pictures of Pluto, and it was a weirder, more complex world than anybody ever thought. It has mountains made of ice. It has glaciers made of methane that move across the surface, and it probably has some amount of cryovolcanism, volcanoes of ice. So one interesting feature on the surface of Pluto was a giant crater that the astronomers called Kaladze. And it was really unusual because you had this sort of large region in the crater that was filled with water ice, and then that was surrounded by a larger plain containing these methane glaciers. And so astronomers wondered, like, what happened? Did a giant rock crash into Pluto, and then it dug deep down and it caused this crater to overflow with water ice onto the surrounding terrain? But a new theory is that it's actually a supervolcano, a cryo-super-volcano. And so when they did the math, looking at the impact of this region, they estimated that if it was a supervolcano, it would have released about 1,000 cubic kilometers of water from inside Pluto out onto the surface of the planet. Oh, I said planet. Oops. You're welcome, Alan Stern. All right. And I just love this idea. Like, when you think about some of the supervolcanoes that have happened here on Earth, there's one that happened in Indonesia. There's the potential for one at Yellowstone. They are catastrophic events. And yet Pluto, which is this incredibly cold planet, really far away from the sun, is so active that it could still have supervolcanoes. But instead of erupting liquid rock, it's water. It's an icy cryo-supervolcano. Anyway, I hope this is true. I really hope that they learn more about this and more evidence is gathered. I really like the idea of how in the outer solar system, all of the things that we are familiar with here on Earth exist on these other worlds, but everything's just shifted by one phase of matter. On Earth, we have mountains made of rock, and we have volcanoes that are erupting with molten rock. On Pluto, you have mountains that are made of ice, and you have volcanoes that are erupting water. And on Earth, our atmosphere contains oxygen and nitrogen and carbon dioxide and methane and other kinds of gases. On Pluto, many of those have frozen out into glaciers that cover the surface of the world. It's such a bizarre place, and it's kind of familiar, and yet it's alien. Webb looks at Kuiper Belt objects. Speaking of objects in the Kuiper Belt, there are some really interesting worlds out there which are not Pluto. Now, there's a bunch of objects that are like Pluto that are in the Kuiper Belt that are very similar in their characteristics. You've got Pluto, but then you've got Eris, you've got Makemake. Like, these worlds are icy with methane on their surface, very familiar. But there are some other worlds that are on very extreme orbits. The classic example of this is Sedna, which is possibly on a 10,000 year orbit. And so what kinds of changes happen to a dwarf planet as it moves in and out of the solar system by that degree? So astronomers have questions, and so they pointed the James Webb Space Telescope at these dwarf worlds. Specifically, they analyzed the surfaces of Sedna, Gong Gong, and Quaoar. And the goal was to really figure out, are these worlds any different from those other objects that are a lot more like Pluto in the Kuiper Belt? And they found that they were. They found a lot of really interesting chemicals on the surface of these worlds. Things like ethane, oxylene, acetylene, things that are the byproducts of methane. And you only get this if you've got a fresh source of methane that's appearing on the surface, and then sunlight is breaking down these chemicals into these other chemicals. And so that means that there has to be some kind of active process that's going on these worlds, whether there's geysers, cryovolcanism, whether there's some kind of seepage of methane from the inside of, are they farting? Anyway, some kind of seepage of methane coming from the inside of these worlds, and then it's reaching the surface, and then it's interacting with the sunlight, it's breaking down and leaving these other chemicals on their surface. And again, we're just learning that the outer solar system is just a lot more active and dynamic, and the worlds out there are a lot more like planets and places in the inner solar system, and not just these rock hard frozen balls of water ice like we used to think. Now, when we record each episode of Space Bites, we're only including less than 10 stories. But at Universe Today, we are covering 20 to 40 stories every week on the website. Stories that we just don't have time to get to here on the show. So if you want a more comprehensive look at all of the space news that is breaking this week, you should sign up to my weekly email newsletter. The thing is gigantic. It is, we'll sometimes have 30 to 40 separate stories in it. I write every word, and so you get this very consistent voice coming from me. There's no ads in the newsletter at all, and it's completely free. So if you want to get like a weekly dose of space news, like I'll warn you in advance, this thing's going to take you a couple of hours to go through and bring yourself up to speed, but you will be better informed than anybody else about what's happening in space and astronomy. So go to universetoday.com/newsletter to sign up. A monster solar storm struck the Earth 14,300 years ago. People always ask me if I'm worried about asteroids, and I'm not really. They happen very rarely. Very rarely will an asteroid impact the Earth. And we showed with DART that we can actually fly a spacecraft out, and we can smash into an asteroid, and we can change its trajectory. And so within a few decades, we will have identified all of the dangerous asteroids. We will figure out how to move asteroids that are a threat, and we will have minimized one of the universe's big threats against Earth. What else you got, universe? Well, a lot. And the one that I am worried about is solar storms. And the sun occasionally can throw off these coronal mass ejections, throw charged particles at the Earth, radiation, and it can do a lot of damage. In the past, we were protected by our atmosphere, and we didn't have any technology, and so they would give us a really great aurora display, go out see the northern lights, and that's it, like a fun evening to watch the night sky light up. But now, with all of our technology, all of our satellites, all of our interconnected electricity grid, we are at a lot more of a risk to solar storms. And now astronomers have worked out what was probably the most powerful solar storm that's hit the Earth in the last few tens of thousands of years. The one that you're probably familiar with is the Carrington event. It happened in 1859, and it was so powerful that it lit telegraph poles on fire. Can you imagine what that kind of a solar storm would do to us today when we have much more infrastructure than just telegraph poles? We have an entire electrical grid that covers all of our parts of the world. We have electronics in pretty much everything that we use. We are very vulnerable. Researchers looked at the tree rings of trees in France, and they were able to trace back to over 15,000 years ago. They were able to see when various solar storms had hit the Earth. When a solar storm strikes the Earth, you get the generation of isotopes of carbon that make their way into trees, and they're incorporated into the growth of the tree. And you get this record of when these various events happened. And some of the most catastrophic events, they're called Miyake storms. They've known about 6 of them that have happened over the last few tens of thousands of years. And now scientists have found the big one, the biggest that was like twice as strong as the most powerful Miyake event that had ever been seen. It happened about 14,300 years ago. So that's like before modern society, but there were definitely people around when that event happened. And the crazy part is that the Carrington event that happened in 1859 isn't recorded in the tree rings. Like, it wasn't powerful enough compared to these other solar storms. So that's a big one. Now, I'm going to talk a bit more about solar storms at the end of this episode, so stay tuned for that. Turning a problem into a tool. Astronomers mostly hate cosmic rays. These are protons, mostly, that are accelerated to enormous velocities, just close to the speed of light. They're probably coming from supernova. They might be coming from pulsars, other extreme objects, maybe the accretion disks around supermassive black holes. Astronomers aren't entirely sure where they're all coming from. But when they hit the atmosphere going almost the speed of light, they cause this shower of particles, and astronomers call this an air shower. And they show up as streaks in their images. If you're unlucky, that particle is going to go right through whatever object you were looking at, and now you're going to lose a bunch of data. But astronomers were wondering, like, could we do something with these air showers, with these cosmic rays as they hit the atmosphere? So a team of Japanese researchers went back through tens of thousands of images taken by the Subaru telescope, and they were able to find about 13 examples of extremely powerful air showers. And they were able to get enough good information that they could then pass that along to particle physicists, astronomers that study cosmic rays, and they can use that to try and identify what the sources are, trying to understand the kinds of energies that were involved. And so if you've got an astronomer who gets an air shower coming through one of their images, they can pass that along to a different kind of astronomer who can then use that as a way to understand the universe a little better. So I guess that's making lemonade from lemons. Now I'm going to talk some more about solar storms and like what practical things we can do about it. But first, I'd like to thank our patrons. Thanks to David Richards, Mark Ansis, Antonio Lofilara, Dustin Cable, Vlad Shiplin, George, Andrew M. Gross, Jeremy Mattern, Josh Schultz, and Jordan Young, who support us at the Master of the Universe level, and all of our other supporters on Patreon. So I hope I didn't scare you too much about the potential damage from solar storms. I mean, it's something that we should definitely be aware of and concerned about. And that's why there is so much work that's being done to better understand the sun. We've got the Parker Solar Probe. We've got the Solar Orbiter. We've got the Daniel K. Inouye telescope on Earth. There's a new Chinese telescope that's been built. There's a new Indian satellite that's been launched that's going to go and study the sun, not to mention all of the other spacecraft that are already in place studying the sun. And the goal is to try to match events that are happening on the surface of the sun with the kind of space weather that reaches Earth. And with a bunch of these spacecraft that are actually closer to the sun than the Earth, they can give us an advance warning. They can spot some kind of event on the surface of the sun, a flare, or some kind of conditions that are likely to cause severe space weather, and then give us a warning. What can we do? Where we're at right now is the world's governments are starting to develop better and better warning systems where they can send out an announcement to your phone and say, oh, there is a potentially dangerous solar storm inbound. And then you can know to go around and unplug all of the devices in your house that you think are going to get fried. And then you can decrease the amount of electricity that you're using so that if there is a really powerful solar storm that hits the Earth, it's going to minimize the amount of its impact. But you can do other things as well. Like there's just like standard disaster preparation that you should all be doing. You know, where I live, earthquakes are the thing. And so you want to have a bag that is filled with emergency supplies, water, first aid equipment, things like that. You want to have a plan for your friends and family if there is a problem that you guys can meet up or help take care of each other and make sure everyone's safe. And then, you know, if you're concerned about your electronics, I highly recommend an uninterruptible power supply that is plugged into the wall and then you plug your devices into it. I have one for this computer and I have one for my internet devices, and my power goes out all the time. And whenever it does, the whole power in the house goes out, and yet I still have my computer and I still have my internet, and I'm able to keep doing some work while I wait for the power to come back online. So if you don't already, put together a disaster bag. Put an uninterruptible power supply in between the wall and the devices that you care about, and just learn more about how you can be prepared for the possible solar storm. And hopefully we will learn more and more about this and sort of take action at a societal level to minimize the damage from them. All right, that was all the news for this week. We'll see you next week.